Okay, as I was mentioning with Revit, you always draw your project and start your project so that the major axis of the building is aligned with the Revit screen. Now, okay, so here's the Revit drawing area. So if you have a building that has a second wing on it, a secondary wing, that's fine, but keep the major axis of the building, its long axis, aligned with the drawing area. So you can either draw it horizontally or vertically, whichever suits, so that you have project north for the project pointing directly up on your screen. Tonight we're going to be talking about how to make your building's project north and the true north for the project. So you're pointing at geodetic north or north on the compass. So true north might be in some other direction, that's fine. Ignore it for now. What we're interested in is just getting that building drawn, aligned with your screen, forget about true north, wherever that might be pointing, put the building on the page in such a way that it makes the most sense, aligned with your drawing area. All right, so the next thing we're going to talk about is Revit's own internal coordinates and how it deals with the outside world. So in your level 1 plan view here, if you folks go to the visibility dialog, VV on your keyboard, just type in S on your keyboard to take you down to the S categories in this dialog box. Go to the site category and expand it. So the first set of coordinates that we're going to be talking about with Revit, you can refer to your notes for this, is project coordinates. So project coordinates is Revit's own internal XYZ grid for just figuring out where everything is in its own working space. So just like AutoCAD has its world coordinate system, Revit has its own coordinate system, the 0 point of which you can see if you turn on the project base point under the site category. So when you hit OK, you're now going to see the circular icon in the middle of the screen. So this icon is 0, 0, 0 in Revit's own coordinates. Does it matter where you draw your building with respect to this blue circle? And the answer is generally no, with one major caveat. Revit requires that you draw your project and all other data associated with the project within a 10-mile radius of this icon. 10 miles maximum. So that means, of course, a diameter of 20 miles. So 10 miles within this icon. So if you're importing an AutoCAD drawing into this view, say from your surveyor or from your civil engineering consultant, it means that all of the geometry in that AutoCAD drawing also needs to be within a 20-mile radius. So with ACAD, AutoCAD bringing in that geometry, it means and this might sound sort of arcane for those of you who aren't familiar with these AutoCAD terms, but you have to be within 20 miles, or 10 miles of course, 10 miles of the world coordinate system 0, 0 in AutoCAD. So when you folks draw a line in AutoCAD, so you L space and then 0, 0 space, that's 0, 0 in AutoCAD. So you need to make sure that there's no data that's outside of that 10-mile limit and then gets imported into Revit. And you're like, well, why? What's the big deal? Well, Revit is built on a Windows technology called DirectX. Those of you who know anything about Windows technology, you've heard of DirectX, and you've probably seen some noise in Windows updates or drivers or something like that about DirectX. So it's a part of Windows that puts stuff on your screen in a fast manner. DirectX is really important for showing vector-based graphics, so the walls, all the geometry that you see in your 3D model. DirectX does that for Windows in the background. And the problem with DirectX is that it has a finite coordinate system, a finite number of integers with which it can show data on your screen. Now, Revit's own internal coordinates are just as accurate as AutoCAD, so they call it floating point precision. Don't worry about what that means, it's super accurate. But DirectX begins to fall off the wagon once you get a long ways from this 0, 0 point. So if you guys start drawing way off in the boondocks in Revit, you see that your curves would begin to look really faceted, like this. Your curves would no longer look smooth. It would show us great big facets. And the software geeks call that tessellation, but whatever. So you want to make sure that you stay within 10 miles of this icon. And of course that's easy to do unless you're doing an airport or some big, massive transportation project. So this is one of the reasons that Revit is not likely to be used by the road building industry. Question?
So if we have something out of this scope, does we need a message?
Yes. Yeah, so the question is, what happens if you do have something that's larger than that? Revit will let you do it, but it'll give you a warning that you could have some display weirdness. So that's why you want to avoid it, if at all possible. Now, since most of our projects are never going to be anywhere near that size, it really doesn't matter where on your screen that you draw your building. So if you draw it over here, or if you draw it over here, or if you draw it right smack in the middle, no big deal. Now, for those of you who have worked on big AutoCAD drawings, you've probably used 0, 0 in AutoCAD as a point of reference so that when you're using external references from your consultants, you can bring them all in and have a common origin for those XREFs when you're importing them so that they all land in the same place. So that way the structural engineer's drawings lay right on top of the survey drawings, on top of the mechanical engineer's drawings, right? You just import it at 0, 0, boom, you're done. So in Revit, you could use the project base point for that, but in my experience, people don't bother. The coordination process tends to come along a little bit farther down the line, so it's unlikely that you will use the project base point as a point of reference. You can move this icon, and when you click on it, you folks can see that there is a paperclip. And if you unclip it, you can move it. Now, this will not change the rule about that 10-mile radius around this icon. So if somebody legalizes pot usage in your office and somebody gets really stoned and draws your building like 10 miles off in the boondocks, and all of a sudden you're like, oh shoot, what am I going to do? You're like, oh, no problem. I can unclip it and I can just grab this bad boy and move it off to where I've drawn my building. Sorry, no such luck. Revit's own 0, 0 point for figuring out how to draw curves and figuring out how to draw lengths of walls is still in this original location. So even if you unclip and move your project base point, you're not out of the woods on that particular front. Now I can right click on it and you can see I can move it back to its startup location. So the original location of the project base point still matters. So there it is. So you can unclip it and move it, but and then you can use it at that point for coordination purposes. But what people generally do is they use the other set of coordinates in Revit for coordination purposes, and these are called shared coordinates. So if you folks type in VV on your keyboard, and again go down to the site category, let's turn off the project base point and turn on the survey point. So in your visibility dialog, turn off the project base point. This will hide that circular icon. And now we're going to turn on the survey point, which is a triangular icon. Now, the project base point can be easily moved with perhaps frightening ease. There, I just moved it around. What the survey point is meant to be is a point of important reference for the entire project. So the survey point becomes a home base for the team. So when we're bringing all the different models together from all of our Revit-based consultants, we use the survey point as that home base, so that all of the consultants' projects will have this icon in the same place in all of their projects. Not only that, now if you folks want to go to the south elevation, just double click, and again go to your visibility graphics down to site and turn on the survey point again. So you can see it sitting off to the side there where I moved it. The survey point is used for telling your project how high it is above sea level. So that's probably not something that you've broached yet in your use of Revit if you haven't talked about shared coordinates. So what we will do is we will move the survey point downwards by a specific amount. So this will represent sea level. So we're going to have our main floor at whatever height that it needs to be above the survey point. And we move the survey point downwards. Now, if you folks have ever had to, or if you've ever tried to, go into 3D. So here, I'll just grab a file here. So if you ever tried to grab a whole Revit model and move it, it's not fun. If you ever tried to take a whole Revit model and move it up and down somehow, that isn't fun either. So I'm going to bail on the upgrade here. What we do instead of grabbing the whole model and moving it up and down, is we leave the model where it is. And instead, we move the survey point up and down to represent a change in the project's elevation. So when you're setting out a building and you wanted it, say, 202 feet above sea level, and then somebody comes back and says, you know what, we need to raise the building an extra foot. So instead of grabbing the building and moving it up, we grab the survey point and move it down. Now there's actually a different process that we're going to go through, and we'll talk about that in a few minutes. But essentially what happens is we leave the building in place, and the survey point moves to represent the building's new adjusted height above sea level. Now, we talked about Project North and True North. So I'm going to go back to the level 1 plan view here. And what I want you folks to do is now go back to your visibility and turn on the project base point. So now the two icons will be visible. Project base point and the survey point. So when you click on these icons successively, you will see that they have a green axis and a red axis. The green axis is the north-south axis, and the orange axis is the east-west axis. So both the survey point and the project base point have their own north-south axes. So what's going to happen is that the project base point is going to retain the vertical orientation of that green axis. Project North is going to point straight up on your screen. But what is going to happen is that the survey point's green axis will rotate to point at True North. So vertical on your screen. And if we want true north, if we need true north to point in a different direction, we're going to talk about at least 2 different ways where we can make that happen. So we're going to be able to take the north-south axis of our survey point, shared coordinates, and we'll be able to rotate it in whatever direction is necessary to point to geodetic north for our project. Here's the first method. If you click on the project base point, you'll see that there is a blue row there that says angle to true north. So we can manually put in the declination between project north and true north. So if I want here, I can put in an angle of 10 degrees. And it doesn't look like anything's happened. Our survey point's moved a little bit. But now when we go back and click on it, we can see that it's been rotated 10 degrees. So one way of setting true north is by typing in the declination between project and true north at the project base point. So here I can go back and set it to 0 again. So that's one way we can do it. Now, what I'm going to get you folks to do is wherever your survey point is right now, just go draw a detail line, so DL on your keyboard. And we're going to just draw a line here on an arbitrary angle. So let's say that that angle that you see right there on your screen is the direction to true north. So to set that up, let's go over to page 3 of the notes. So looking at the bullet points on the bottom of page 3, so we've talked about the first bullet point icon where we can select the project base point and then type in the declination angle ourselves. Now we are looking at the second option. On the Manage tab, if you folks find the, I think it's the coordinates drop down or position menu. Anyway, it's this one. It's the bottom of the 3. I don't have text showing because I've changed my screen resolution to suit the screen. So here we've got rotate true north. So if we pick rotate true north, Revit kicks us into a command that's very much like the rotate command. Now, can't use the rotate true north command until we make a change to this view. And here's the change that's required. In the properties for your view, you'll see that the orientation is project north. So all new views, new plan views, and ceiling plan views, when you create them, by default, Revit sets them to project north. What does that mean? Well, it means the view is aligned with the green axis on the project base point. So change the orientation to true north. And if your screen's rotated, just stop for a second. We don't want the screen to start rotating if you're set to true north. So switch it back to project north. So before you do this next exercise, you need to make sure that your project base point says angle to true north equals 0. So make sure you've got that set first. Now, once you've got that confirmed, deselect the project base point and go back to the orientation parameter and switch it to true north. Nothing should happen on your screen. So now this view will show you the project's true north orientation, but we haven't set it up yet, so we need to go back to the menu here for rotating true north. All right, so once we've done that, just like the rotate command. Now what we want to do is move the axis of rotation to where we have our north arrow. So hit the space bar, and it turns your cursor into the rotation icon. Move the icon to the south end of your north arrow. Now if your north arrow happened to be up here somewhere, that's fine. So I drew the line right off my survey point. It doesn't matter. What it matters is that you put the cursor at the south end of your north arrow. So what we're going to be doing here is taking true north, this axis, and rotating it so it's vertical on the screen. So watch up here on my screen as I do this. I pick the south end of the north arrow, click number 1. Click number 2 is picking the north end of my north arrow, and then bringing it up so it's vertical on the screen. And you can see what's happened. My whole view has rotated. So you can see the orientation of my elevation tags now. And now I can switch my orientation for the view back to Project North. So in your floor plans, of course, you'll maintain your Project North setting. But if you go to your site plan, in this view, you may indeed want to show the project's true north orientation. So now you can have both. True north in your site plan, Project North in your floor plans. So what we're going to do now is we're going to show you how to do this in the term assignment for the project. So what you folks need to do is go to the iDrive and copy the term assignment to the desktop of your computer just for this exercise. So I have to connect to the BCIT network from So I'm going to go to the share out directory here and then BLDG. Go to the 2805 folder, and there's the term assignment folder for the 2805 course. So just right click on it and copy it and then paste it to your desktop.
Sorry, which one is it?
Just grab the whole term assignment folder. Yeah, on the J drive. So share out BLDG 2805, right click and copy it, and then paste it to your desktop. Now, we're not going to be starting the term project yet, but we are going to be looking at one aspect of setting up the term project, and this is on page 4 of your notes. So what you folks need to do now is go to the open dialog box in Revit, Control O. So Control O to open up the file dialog, and then go to the term assignment directory and find the site model, and we will update it to the 2020 file format. I'll probably do that after class tonight. And just open this up. So it's going to take a second to convert it into the 2020 format.
Sorry, which model is it?
Yeah, site model 2019. Okay, if any of you haven't found the site plan yet, just wave. Henry and I will get you sorted. Okay, so in the notes, step 2, note the north arrow on the right side of the survey. So right down here. So that is our surveyor's north arrow. So in this case, we need to rotate the shared coordinates of this project so that our north arrow is pointing straight up. So what we need to do is change the orientation parameter here in the properties palette from project north to true north. So it's project north right now, switch it to true north. And there you go. So as it says in the notes, nothing's going to happen until we actually use the rotate true north command. Henry. Got a couple folks over here who need a hand here. Oh, yeah. Okay, anybody else needing to get that fixed up? Okay, so what I'm going to do, folks, and you'll have this on YouTube, so if you're losing track right now, it's not a big deal because you'll have the video to check it out later. So on the Manage tab, from the same drop-down menu, find Rotate True North. And so now again, what you need to do to start the rotation process, hit the space bar. So that moves your axis of rotation to your cursor. So now you pick the south end of the north arrow, move your cursor there and click it. Then you're going to choose the north end of our north arrow, click it, and then rotate the north arrow so it is in fact pointing straight up on the screen. And once you've done that, you folks will see that with your orientation set to true north, the north arrow is in fact pointing straight up on the screen. So what we kind of talked about these last few minutes is that the project base point, that's an internal thing for Revit, and true north, we're going to do a few things with it. We're going to move it into a location on the project, maybe a property line corner or a grid line intersection. That makes a good point of reference for the team. So that's a plan movement. We move the survey point into the right location in plan. Then the survey point gets moved, typically downwards, unless you're Israeli and you're at the Dead Sea. You typically move the survey point downwards until it gets to a point that represents sea level. Then lastly, you're going to rotate shared coordinates so that shared coordinates, its north axis is pointing to the North Pole, regardless of which way you orient your building. So those are the three different things that we do with shared coordinates. And once that's been set up, typically the architect's office will set that up. And then you start bringing the other consultants on board, and we will explain that in the second half of tonight's video. So folks, we'll take a break, and then we'll come back in 10 minutes and we'll carry on.